Hello classes, hope you're all doing well. We're going to talk about section 6.4 today, inverse functions. Alright, here we go. Inverse functions. What does inverse mean first of all? What does that mean to you when you hear the word inverse? What it means to me, it says the word inverse is related to the word invert, which means to reverse, to turn upside down, or to do the opposite. So, when I think of the word inverse, these are the things that are going on in my head right here. So let's look at an example that means what it means to do the inverse. That's what you're going to do today all day. You're going to find the inverse of things, or tell me if two things are inverses of each other. Let's look at this relation right here. So you got this relation, which really is these coordinates, right? Same thing, just different ways to write it. What would it mean if I said, what is the inverse of that relation? What does that mean? Well, what did it say? To switch, what is the exact wording we had here? To do the opposite, do the reverse, turn upside down. I think to switch. That's how I think of it. Or to do the opposite. So instead of 1, 2, we're going to do 2, 1. Instead of 3, 4, we're going to do 4, 3. And 6, 5. Look what happened. 1 and 2 reversed, or they switched. Okay? 3 and 4 reversed. The opposite happened. Instead of 3, 4, 4, 3, so on, so on. That's what it means to reverse. So X switches with Y. Okay, that's what happens on a simple level. The X value switches with the Y value, and that's what it becomes. Alright, now that you know how to find the inverse of a relation right here, I'm going to show you what always happens with the inverse. Okay, so here you go. I'm going to graph this relationship right here, and which is here. I've already graphed. In the red, I've graphed those coordinates 1, 2, 3, 4, 5, 6. They're in red up here. Now what I'm going to do is I'm going to graph the inverse. So let's see. I'm going to put those in. We'll put them in purple. Okay. So the inverse of that was what? It was 1, 2, 2, 1, 3, 4, which means 4, 3, and 6, 5. There was the inverse which we said earlier, right? So let's graph those. 2, 1, 4, 3, and 6, 5. So 6, 5. You notice anything between the red dots, which are the 1, 2, 3, 4, and 5, 6, and the inverse dots. So the red dots and the purple dots. This always happens. They're always reflected over the line y equals x. So inverse relationships are, I'm not going to write it again, they're always, so I say always, reflected over the line y equals x. Okay? You're going to see that here in a minute. Alright, so on to example number 2, or number 1, really. So, here we go. Alright, find the inverse of y equals 3x minus 5. Now, what I just showed you earlier was you just taking coordinates and then switching them around, right? I'm not going to give you a question like that. Too easy, right? I'm going to give you an equation and I'm going to say, find the inverse of this equation. Well, what happened in the coordinates, x and y, 1, 2, 3, 4. What happened with these? You switched x and y, right? So x was now y, y became x. You just switch them. That's exactly what you're going to do here. Whenever you see, find the inverse of this, you're going to switch x and y. That's the key. Alright, so that's step one. Switch x and y. Step one. Switch x and y. Let's do it. Y equals 3x minus 5. Switch. X equals 3y minus 5. I just switched x and I switched y and then put them one over here, one over here. There it is. Now, step two. After you switch x and y, you only have to do one more thing. Step two is solve for y. There you go. Let's do that. So we got x equals 3y minus 5. Let's get y by itself. That's what that means. Solve for y. Get y by itself. Alright, so to get y by itself, we need to plus 5 first to both sides of the equation. X plus 5 equals 3y. Get y by itself by dividing by 3. Divide everything by 3. Everything by 3. This is it. Y equals, those cancel, that makes a y equals x plus 5 over 3. Now if that reduced, you can, but it doesn't, so this is it. You just found the inverse of this guy up here. So basically you found the opposite of this. The opposite of this is this. If you took a moment to graph this, if you put this in your graphing calculator and looked at that line, and then you put this in your graphing calculator, you would notice that they are reflected over the line y equals x. Just like those coordinates were, these are reflected over y equals x as well. Okay? Actually, I'll probably show you a picture of that soon. So, that's how you find the inverse. Switch x and y. Alright, on to example number 2. So number 1 was, can you find the inverse of an equation that looks like this? Any equation, really. Number 2 is verify that these are, in fact, inverses. Like this is the inverse of this, which means this is the inverse of this. Okay? So how do you verify that things are inverse of each other? Well, I kind of took this to a different page and to show you more space here. Same problem. I just said the second one is g of x instead of, this one says f negative 1. If you've never seen that before, which you should have, this little negative 1 power means inverse. That means the inverse of the function f. So if this is f, right here, here's f, then this is the inverse of f. Okay, it's the opposite of f. That's what it means. So get used to that kind of math terms right here. F of x, f negative 1 of x just means the inverse of f. Okay? So back to how do you do it? How do you verify? Well, you have to do this. To verify, you do find, number 1, find f of g of x. Like composition, remember last section, section 6.3 was composition. So compose this and this. That's f of g of x. And it has to equal something. It has to equal x. If it's not equal to x, then they're not inverses. Number 2, there's only 2 steps. Find the other way. Find g of f of x. So compose this one with this one. So just doing both cases really. And it has to equal x as well. If this happens, then they are inverses. Sorry, it's a little sloppy. Inverses of each other. this is the inverse of this, and vice versa. This is the inverse of this. Okay? So this is all about verifying. Example 2, star that. This is what you need to do. Okay. Here we go. Let's do it. Let's find f of g of x. Alright, so first thing I do is I substitute g of x with whatever is written up here. G of x is 1/3 x plus 5/3. Now what does this mean? F of 1/3 x plus 5/3. Now I pretend this f of 2 means, oh, I put 2 into f. Oh, right there. Oh, boom, I'm done, right? But this is f of all this, so I got to put all of this in for x up here. So this is equal to 3 times, instead of x, that's what it was before, now 1/3 x plus 5/3. And then we still have minus 5 here. So minus 5. Everybody understand what I did? I just substituted x for all of this. Watch what happens. 3 times 1/3 x is, 3's cancel, that's x. 3 times 5/3 is plus 5. And we still have minus 5. Look what happened. This is equal to x. So f of g, this first one, is equal to x. Now we have to find g of f. Make sure it's equal to x. I don't have room on this one, so I'll make another one here. 2 cases. F of g we found to be x. Now we want to find step 2. Find g of f of x, which is equal to, let's see, off to the side, what was it? 3x minus 5 was f, and g was 1/3 x plus 5/3. Alright, so g of f, instead of f, I'm going to put what f is, which is 3x minus 5. This is equal to, plug in this wherever g is. So here's g, so plug in this where I see an x. There you go. So 1/3, instead of x, I put 3x minus 5. Substitution, I still got plus 5/3. And all you have to do now is solve. 1/3 times 3x, that's x. 1/3 times 5 minus 5 is minus 5/3. Now you still have plus 5/3, which cancel out. This is equal to x. So what you had here was f of g was equal to x, and then right here was g of f. So g of f was equal to x, which means they are inverses. Correct. Okay? That's how you know, that's how you verify that two things are inverses of each other. So all that work showed us that this thing, this function, and this function are inverses of each other because f of g equals x and g of f equals x. That's how you verify. Example number 2. Okay. Alright, here we go. Example number 3. Word problem in this section, and it's different. So I want you to star this because people miss this a lot, and it's an easy question. So watch this. Here's why people miss it. But here we go. Elastic band. So think of a rubber band. You know, exercising. There's resistance. Once you start pulling on that rubber band, it gets harder. You know, it gets harder to pull. So there's resistance there. A band's resistance, R, resistance, in pounds can be multiplied by the resistance is equal to 3/8 times L means the length of the stretched band minus 5. So all they did was take this situation and make a function out of it. R equals 3/8 times the length of the band minus 5. Okay, now you see an equation. Now it asks us this question. Find the inverse of the model. We want to find the inverse first. Now hold on. Okay, so people will do what they did for example 1, right? You switch x and y, and then no, that's not how you do something like this. Whenever you deal with a word problem, whenever it's like real life situation like resistance and length of a band, all you have to do is solve for the other variable. Okay? Solve for the other variable. Okay? Meaning this, let me give you a situation. Okay? Let me try to make it more applicable. Let's say this. Let's call me S for Swinger. Okay? Swinger, Mr. Swinger, is equal to a, I should have used something else, student, which we'll call M, plus 50 kilos. Alright? So S will make, Swinger's weight. Don't be laughing. Here we go. M is the student's weight. Right? So I'm just making this up. So my weight is equal to one of your weights plus 50 kilos, we'll say. Alright, now if I said find the inverse of this right here. You don't want to switch these two and then solve. All you want to do is solve for the other variable. Solve for, in this case, and right now it's solve for S, right? S is by itself, which means it's already solved for S. You want to solve for M. How do you solve for M? Real easy in this case, right? Minus 50, minus 50. Get M by itself, which makes M equal to S minus 50. This is the inverse of this. Okay? If you plotted these coordinates here, if you found these coordinates and you found these coordinates, you'll notice that their coordinates are flipped. They're switched. Okay? This is all you have to do for a real world problem. Just solve for the other variable. I can't stress that enough. I can't tell you how many people just treat it like the y equals x plus 2 and then solve, put x over here, put y over here, and then do all that like example 1. I don't want you to do that. Not that that's totally wrong, but this means the same thing. It means something better. Okay? It's a better way of doing it. So, this is how you do it. Here we go. Let's try it. Alright, so if we want to find the inverse of this thing right here, all you have to do, solve for the other. It's already solved for R, right? Solve for the other one. Okay, let's solve for L right now. What do we have to do first, though? We'd have to plus 5 first. So let me rewrite this. R equals 3/8 L minus 5. So you'd have to get L by itself. So plus 5, plus 5. You have to do the right order of operations here, backwards. Okay, so R plus 5 is on this side. Equals, this is gone, 3/8 L. How do you get 3/8 out of here? Well, this is 3/8 times L. So you don't want to divide by 3/8. You want to multiply by the reciprocal, 8/3. Multiply this by the reciprocal. Whoops, 8/3. Okay, times this whole side. This is what people miss right here. They put 8/3 out here and won't multiply to the whole side. So 8/3 times this whole side. These cancel. That's 1L. So L is equal to, if I distribute, that's 8/3 R plus 8/3 times 5, which gives me 40/3. There you go. This is solve for L. This one's solve for R. This one's solve for L. That is the inverse of the function. Now, why would you want to do that? What does that matter? Why not do the other way? Because the other question is this. The other question is find the inverse of the model. No, that's what we just did. Use the inverse to find the length at which the band provides 19 pounds of resistance. So what we found was, we found L is equal to, the length is equal to, say, 8/3 R plus or minus, plus 40/3, right? That's what we found the inverse to be. That was part 1 right here. Part 2, use this to find the length. Look at that, find the length. If the length was on this side, it'd be harder to find. It's easy now. Find the length when you have 19 pounds of resistance. It's telling you R. All you have to do is plug in R. 8/3. R is 19 pounds plus 40/3. L equals, all you gotta do is type that in your calculator and you get 64. Just take my word for it, or actually I would, if I were you, type all that in your calculator, make sure you can get 64. But 64 what? It's a word problem. Find the length. 64, it said L was the total length in inches, so 64 inches. There you go. So the key here is whenever you do a word problem, please just solve for the other variable. Right here you solve for R, you need to solve for L, and that is the inverse. Can't stress it enough. There you go. Example 3, the word problem